Hello everyone. So in this video, I'm going to walk you through some practical examples of doing hypothesis testing in R. This code demonstrates how statistical theory is applied in real data analysis. And I think for the most of this script, I will be using a diamonds dataset, which is inbuilt. And it has information on approximately 54,000 diamonds, including characteristics like price, carat, cut, color, clarity. I'm not a diamond expert, but this is a large data set and it's useful to have. So we begin by clearing the memory. So start with a fresh clean slate. We don't need any fancy package for these tests. So ggplot2, because we want to plot some fancy looking figures, and the deployer package for data manipulation. So let's take a look at what the data has. So this is a summary of the data. So there is carat, cut, color, clarity, depth, table, price, and then some XYZ. What there is in this data set is not super important. What we are more focused on is how to do hypothesis testing. So we begin by looking at a basic one sample t-test. And our hypothesis is this. We want to check if the average diamond price differs from 4,000. So we set up as follows. We set up the null where the average is equal to 4,000, which is the mean price equals 4,000. And the alternate is the mean price does not equal 4,000. So to do this, we use the t-test, this function t.test. It's a simple function where it takes in the data set, it takes in the value, it takes in the variable that you're interested in, and it sets the mean price against which you are comparing. So we run this code. So this is stored in this object called one sample test, and we can print the data. So what we have over here is that we have a t-stat of negative 3.91, degrees of freedom 53,939, and the p-value of 9.159 e to the power 8. This means 0.5 zeros followed by 9. So the p-value is almost as good as 0. So we can reject the null that the mean price is equal to 4,000 and go in favor of the mean price differing significantly from 4,000. This block of code is a nice way of displaying your result. So what it does is that so it checks, so it is an if-else statement. So if the p-value from this test is less than 0.05, because we are testing at a 5% significance level, it will print these two lines, else it will print these two lines. So if we run this block of code, because we have a p-value which is almost 0, we have this output. So at 5% significance level, we reject the null. There is sufficient evidence that the true mean price differs from $4,000. So that is that. After running, so the second example is about a two-sample t-test where we are working with independent samples. So in this situation, what we do is that we want to test if the mean price of ideal cut diamonds differ from premium cut diamonds. Okay, so we have two different cuts and we want to test if the average price of one cut differs significantly from that of the other. And in order to do that, we set up as follows. First thing that we need to do is subset the data. So we subset the data to extract all the observations with that is corresponding to ideal cuts and all observations corresponding to premium cuts. So we run those data and we have those observations separately. And then we want to perform a two-sided test. The function remains the same, but what goes inside is a bit different. So we want to test if the price among the ideal cut diamonds differs differently from price among the premium cut diamonds, and we print the results. And what we have over here is that we have a t-stat of -24 and a p-value again which is almost effectively 0, which means that these two prices differ significantly from each other. Now suppose we want to run a one-sided test, and we want to test if diamonds with color D have a higher price than that with color G. So our null is D diamonds are not more expensive than G, and the alternate is D diamonds are more expensive than G. So to do this, again, we need to filter the data. So we need to extract these two colors separately. And we have that over here now. So D colored diamonds, there are 6,775 observations. G colored diamonds, there are 11,292. And now we want to perform a one-sided test. Again, the function is the same, but what goes inside is different. So we specify the data set, the variable, the data set, the variable. And now we add an alternative as the greater. So this line over here tells R to run a one-sided t-test. And what we see again is the t-stat is pretty large, which means that so once we run the test, here we see something different. The t-stat is large, but the p-value is 1. So which means that we cannot reject the null over here. And the null is this. D diamonds are not more expensive than G. We cannot reject this statement over here. And we can see that if we run this code. So at 5% significance level, we fail to reject the null. There is insufficient evidence that D diamonds are more expensive than G diamonds. This test also gives you the confidence intervals, the way to up. So in order to do that, we take those one-sided test command where we have stored the results and extract the confidence interval. The first one is the lower bound, and the second one is the upper bound. So most often we use these tests in the context of linear regressions. So suppose we fit a linear regression model. What we see over here is this. So the R reports the t-stat directly. So this is doing a two-sided test where the null is this coefficient in theory is exactly equal to 0, and the alternate is it's not equal to 0. And since the p-value is 0 almost, we can reject the null that this is an insignificant variable. So that is why this is what we mean when we say a variable is statistically significant in a regression. If we want to look at an f-test for overall significance, we run a new model where we look at the price and throw in a bunch of other variables that we think are relevant. We run the model, we take a summary, and we print the summary over here. We can extract the f-stat from this using this command. So multiple underscore summary has everything stored in, which also includes the f statistic, which is then you have the f statistic as the 2 degrees of freedom, and this is the command to get the f-test. So we run this line of code. Okay, so if we execute this, the f value is 0, like it's 0, which means we can reject the null that a model with no covariates is better than a model with these covariates. So this is hypothesis testing in a nutshell. So this is the basic code structure. I hope this was useful.